Welcome students. Here we are discussing a very interesting topic, invertible function. When a function is called invertible, means when we can find inverse of a function. We cannot find inverse of all the functions all the time, isn't it? So we will make it clear here that when a function will have its inverse. So let us discuss here invertible functions. Let us suppose that f is a function defined from set A to set B, and g is defined from set B to set A. Then here function g is called inverse of function f if g operation f is equal to identity function in set A and f operation g is identity function in set B. So when this condition is fulfilled, condition is g operation f is identity function. Identity function, what is identity function? Under this function, image of any element x is itself. Okay. So if g operation f is equal to identity function in A and f operation g is identity function in B, set B, then g is called inverse of f, and we write this g is equal to f inverse or f inverse is equal to g. Correct. So if in place of g we write f inverse here, then therefore f inverse of f is identity function in A and f of f inverse is equal to identity function in B. We can understand it very easily with the help of a diagram. Diagram is very interesting here. Suppose this is set A and this is set B, and a function f is defined here from set A to set B. If element x is here in set A, then naturally under this function f, image of element x will be here fx. Okay. And if g is another function defined from set B to set C, g is function here from set B to set C, and if composition of this function, if you come from A to C, then this will be function being applied here a g operation f. First f will be applied, then g will be applied. So here image of fx in this set C under this function g will be g operation f of x. Correct? So g operation f of x, when you write here g operation f of x, then this is equal to x if g is equal to f inverse. When we define f inverse, the direction will be getting reversed. Correct? So with the help of this diagram, this composition of the function can very easily be defined. Okay. So if we define here f inverse of f and G is F inverse, then this is equal to G operation F. If G is equal to F inverse, and F inverse operation F of this element X will be how much? This is equal to X, this element X, and X means identity element in set, identity function in set A. Okay, so in nutshell we can understand that we can find inverse of any given function if after composition with another function G we will get identity function. Okay, and this is important to note that a function is invertible if it is 1 1 and onto function. We should note it that a function is invertible means we can have its inverse if this function is 1 1 and onto, then only function will be invertible and we can find the inverse of this function. Clear? So in other videos to come we will see some theorems on inverse functions that will be very interesting and useful. So remain in touch with these videos. We have to see some more videos now, and I hope you have subscribed this channel. Please share these videos with your friends also. Wish you all the best.